Well, dear students, in this video again I am going to solve so many problems based on first of all thermodynamics, internal energy, Cp, Cv, and ratio of Cp to Cv. So in this figure here is a graph, pressure volume graph, one complete cycle for 1 mole of diatomic gas. And the process is performed from A to B, then B to C, and then C to A. Temperature at a 400 Kelvin, B at 800 Kelvin, C 600 Kelvin. So which of these following option is correct? Which of the following option is correct? So first one they are asking change in internal energy in whole process is this. So we know in cyclic process by A, B, C, A, it is a cyclic process. In cyclic process, you know, process delta U 0, because internal energy is the function of position, not of temperature, not of process. Path followed पर नहीं है वो, that depend only on temperature. For ideal gas, you know, the internal energy depend entirely upon temperature, ideal gas. So this is wrong, because in complete cycle the change in energy is 0. Now change in energy in process CA, C to A, यानी कि U C minus UA, नहीं UA minus UC, UA minus UC, C से A पाए, finally wrong. So that is equal to diatomic gas. Internal energy of gas is equal to F by 2 RT. I have told you F the degree of freedom. For diatomic gas, degree of freedom is 5. Here F is equal to 5. F the degree of freedom. For diatomic gas, it is 5. So we write here 5 by 2 R into T2 minus T1. Yani 5 by 2 into R T2. 400 minus 600. So it is 200. So 5 by 2 R into minus 200, so it is minus 500 R. While you are given it is 700 R, this is also wrong. Now in process AB, change delta U is change in energy, energy in process AB. AB. So UB minus UA. UB minus UA. 5 by 2 R. Intensity of ideal gas F by 2 RT. F degree of freedom for diatomic it is F5. We have to be very sincere about this. UT 800 minus 400. So it will come out 400 divided by 2 to 1000 R. While it is here minus 250, 350 R, this is also wrong. In process B to C, यानी कि UC minus UB equal to 5 by 2 R or 600 minus 800. So it is now 400. No, sorry, minus 200. 5 by 2 R into minus 200. It is 100. Minus, so it is minus 500. So this is correct only. So this way these questions are very simple. Don't have a prejudice solution in brain. पहले से ही अपने दिमाग में ना कोई सोल्यूशन नहीं होगा. फर्स्ट रीड द क्वेश्चन, follow the instruction given, and then try to solve. I think you will enjoy such questions, and tell your friends and the students studying in class 11 or preparing for exam of AIEEE or main or advanced, whatsoever it is. Such questions are asked. Now other question is there. Here he says an insulated chamber, an insulated container of gas has two chambers separated by insulating partition. One of the chamber has volume V1, pressure P1, temperature T1, and other chamber has volume V2, pressure P2, temperature T2. Like this here, it is a chamber here which is insulated. Double wall means insulated. And there is partition here also. One gas or here the other gas. P1, V1, T1 temperature, P2, V2 and T2. So they say if the partition is removed, then what will temperature mixture? What will the temperature of mixture? Insulated means neither heat come out nor you can give it. The part is removed without doing any work. One of the chamber has volume this. If the part is removed without doing any work, this is a good question here. So what is the temperature of mixture? Because the gas is inside insulated chamber, so internal energy will not change. Internal energy will not change. If final temperature T, then see here. Actually, you know, internal energy अभी मिलता है by 2 RT, and वॉल्यूम कांस्टेंट है, तो CV बराबर क्या हो गया, F by 2R. From here, what is this R? R equal to 2 CV upon F. So if you put it here, you get U is equal to F by 2 into 2 CV upon F T. This cancel, this cancel. nRT. ठीक है, पर मोल तो वही होगी ना. सॉरी, इंटरनल एनर्जी ऑफ गैस, एक मिनट, सॉरी, इंटरनल एनर्जी ऑफ गैस U इक्वल टू F बाई 2 nRT होता है, सॉरी, and we know that CV equal to F by 2R. 4 monoatomic, 3 by 2R, 4 diatomic. So you are not given here which gas is that. F is there. From here, R equal to 2 CV upon F. Putting this value here, you get F by 2 into N into 2 CV upon F into T. So you get NCV T also. You can write internal energy of gas in this form also, NCV T. So if temperature of gas become T, then finally, because no change take place in energy, तो N1 प्लस N2 टोटल नंबर मोल होगा. मान लो N1 N2 मोल थे हम, CV into T is equal to sum of the energy again here N1 CT1 plus N2 CVT2. So from here CV get cancelled. So you get here N1 plus N2 into T is equal to N1 T1 plus N2 T2. From ideal gas equation, P1 V1 is equal to N1 R T1. So N1 is equal to P1 V1 upon RT1 and hence N2 is equal to P2 V2 upon RT2. So we put all these value of N1 and N2 in this equation. N1 P1 V1 upon RT1 plus P2 V2 upon RT2 into T is equal to here N1 P1 V1 upon RT1 into T1 plus P2 V2 upon RT2 into T2. This T1 cancel, T2 cancel, R cancel. So here you get, if you take LCM, T1 T2, so P1 V1 T2 plus P2 V2 T1 into T is equal to P1 V1 plus P2 V2, and therefore T is equal to P1 V1 plus P2 V2 bracket T1 T2 upon P1 V1 T2 plus P2 V2 T1. This option is correct there. I hope you will fully enjoy this question. Yeah, bhai? This is the answer of this question. When we say insulated means heat can neither be given nor taken out from system, and hence internal energy of system remains constant. Now, third question here. This question actually is not asked anywhere but can be asked. Now other question, the last question was asked in 2014, JEE mains, change internal wala, है ना? Now there is a question which is asked in 2018. There is a graph between volume and temperature of gas for volume V of monatomic gas. For monatomic gas, it is temperature and volume graph, straight line. A to B is change the, यहाँ से चेंज गया, तो कह रहा है in process A to B, in changing the state of the gas from A to B. Actually here it is at temperature T1 volume V1, temperature T2 volume V2. So in changing this pressure volume, W be the work done and if Q is the heat absorbed, then what is ratio W upon Q? Undergoing change, the ratio of work done by the gas to heat absorbed in it when it undergoes change from state A to B. So dear student, do you understand when do we get this graph? Such a graph, if V volume and T graph is straight line, having some inclination, with temperature axis, then it is at constant pressure. So heat taken by the gas from A to B for monoatomic gas. Actually, you know Q equal to N Cp delta T होगा. N Cp delta T. The gas is monoatomic gas. The volume monoatomic gas varies. Suppose N mole is there. So constant pressure per Cp for monoatomic gas 5 by 2R. You know why? Cp minus Cv equal to R. For monoatomic gas, Cv equal to 3 by 2R, because F by R. For monoatomic gas, degree of freedom 3 into delta T. Now work done. W is equal to pressure constant है V2 minus V1. Work done equal to pressure into volume. Pressure constant है ग्राफ. Pressure is constant. V2 minus V1. From ideal gas equation, P into V2 minus V1 is equal to NR T2 minus N delta T. So it is NR delta T. So W upon Q. W is NR delta T. Delta T means T2 minus T1. In both cases, temperature is same. Upon N into 5 by 2R delta T. So this come out to be 2 by 5. Here options are 2 by 5, 2 by 7, 1 by 3, 2 by 3, etc. So I hope again you will like it. Solution, please. I am requesting you make these questions viral to your students, friends. Tell the students this way. Actually, I am doing this job for you people so that you should not be exploited in any term. There is another question here. 2 moles of ideal helium gas. 2 moles of ideal helium gas. 2 moles. 2 moles of helium. Helium ideal gas. If they are assuming ideal gas. Are in rubber balloon at 30 degrees centigrade. The balloon is fully expandable. There is a balloon, helium gas filled in this 2 moles. 2 moles of helium gas are filled at 30 degrees centigrade. If temperature of gas is in the balloon slowly change to 35 degrees centigrade, What amount of heat required to raise this in raising the temperature is nearly 62 joule, 104 joule, 208 joule, 124 joule. Because balloon is in air, so it will be expanding in at constant pressure. So heat required to change the temperature delta Q is equal to NCP delta T. NCP delta T. And for helium is monoatomic, तो it is N 2 मोल है और Cp 5/2 R है, delta T only 5 degree. So it is 5 into 8.31 into 25, 25 into 8.31, 25 on the 25 to 75 plus 2, 77, 7 or 207, which is nearly 208 joule. So here it is given 208 joule. So these are few questions I have solved for you. Now you can try this way. Some other question, I have given you the idea of this chapter thoroughly. Please learn all topics I have taught. Make note of in your copy. Please note them and read again and again. In coming videos, you will get next chapter, or may I solve some more questions here. Thank you.